Welcome to the continuing lecture in basics of machining. Next, saddle. The saddle is a part of the carriage that rides on the bed. So, this is the bed, this is the bed. So, the saddle sits on, this is a saddle. It supports the cross slide, which in turn supports the compound rest and the tool holder. So, when you look into the different types of lathe machine, there are turret lathe machine, speed lathe machine, engine lathe machine, these are very commonly used. The latest advancement is CNC lathe machines. Then you have automatic lathe machines, tool room lathe machines, bench lathe machine. Engine and bench, the similar thing, but it is for smaller jobs. Then special purpose lathe machines. So, these are the different types of lathe machines which exist today. So, the turret type lathe machine. So, here the turret lathe machine or the capstan lathes are designed for high volume and duplicate part production. So, here you have a hexagon turret for sequential operation. The hexagon turret, it can be a first tool followed by second tool, third tool, fourth tool, fifth tool, sixth tool, and then when it comes back to the first tool, the next job comes into action. So, it can do facing, turning, reaming, boring, whatever it is, rotating after each task for mass production. With 3 tool posts, they save time, reduced error and are easy to operate even for less skilled worker. So, now in the tool post, when there are 3 tools there, the positioning accuracy of the tool is increased, because otherwise what happens, you remove the workpiece, load it into another machine, do an operation, load it to another machine, do an operation. So, now all the operations are done in a single shot. So, positioning accuracy improves. However, they provide more floor space and ideal for large jobs. Turret lathes are used for making bolts, nuts, fasteners, engine parts, gears, shafts and other precision aircraft parts. When we look at speed lathes, the speed what we talk about is around about 1200 to 3000 RPM, which is very low, but the name was given in early days. So, that still the name is follows. Today, we talk about somewhere between 10,000 RPM to 1 lakh RPM. So, it features a high speed spindle and is commonly used for making items like baseball bats, bowls and furniture parts. It is simpler than the other lathe machine. It has a tail stock, head stock, a turret, a tool turret, but lack a feed mechanism, so that the feed is done manual. Right, is commonly used for operations. So, engine lathe, this is commonly used. The key components are the same. The cutting tool is fed both laterally and longitudinally by feed mechanism. This is very important for the engine lathe, and they are used for making nut, bolt, pulley, gear, crankshaft, etc., etc. This is the latest CNC machines. Here the control what was given in the manual is now completely changed automatic. So, it still has a spindle, headstock, tailstock, a tool turret and control panel, but here the program is written for controlling the movement of the tool with respect to the workpiece. This is automatic lathe machines. Here it operates without manual intervention for high speed heavy duty tasks. Here the tool automatically changes a high efficiency and allows continuous operation. So, here you can try to produce multiple units in a set period of time. Tool room lathe machines, these are otherwise called as high precision lathe machines. They are used for making high precision tools, dies, gauges and jigs. Very small and very precise. Bench lathe machines, these are large machines where the distance between the headstock to the tailstock are very large and you can do big jobs. Here it is very similar to speed lathe and engine lathe. This is a special purpose lathe. So, special purpose lathes are, so here you can try to modify the existing lathe machine itself to meet out to the requirements. So, special purpose lathe machines are designed for special functions, ideal for heavy duty operations for ideal parts. They are used for making wheel lathes, vertical lathes, multi-spindle lathes, T-lathes, tracer lathes, wheel lathes, which it is used for machining rail rods, journal and turn threads, etc., etc. The T-lathes with a perpendicular spindle axis is used for making jet engine rotary machine parts. So, if you look at the production rate, these are the various lathes which are used. For example, computer control lathe machine is used for low to medium volume. When we try to have multi-spindle chuckers, they are used for very high to very high machining. When we try to take engine lathe, it is for low to very low to low type rate machining process. So, these are all the other processes which can be done on a lathe machine: boring, drilling, milling, planing, gear cutting and broaching and sawing. So, here this figure clearly says what is the tolerance we get for the diameter or the length of the job. So, as the length of the job increases, the tolerance level increases. That means to say there is a possibility of defect coming. What is tolerance? Tolerance is you try to give a deviation x plus 10. So, this x is the diameter of the shaft and this 10 is the deviation what it can be. For example, if you take the diameter is 50 millimeter, you can have plus 10, you can have 50 minus 10. It is 60 to 40 is the tolerance. The tolerance which is given is 20 millimeter tolerance is given. So, the part max can be 60 diameter or 40 diameter. So, as and when the length increases, the diameter increases, the tolerance also increases. So, these are the various operations which you can do on a lathe machine. You can do facing operation. Facing is you try to make the tool at an angle. This can be 45 or whatever it is, at an angle, and then the movement what is given is perpendicular to the workpiece. So, now what happens? The face is machined since it is rotating and there is an axis symmetry. So, from the exterior end you have to go only to the half. The rest of the half is already machined when you move from here to here, right. You can put the angle, you can put the tool at an angle and then you can try to generate a feed, a taper surface. So, taper surface are generated when this motion and the cross slide motion, linear motion and the cross slide motion are given together, we try to generate a feed motion. You can also try to generate a profile in the turning. So, that is called as contour turning. And if you have a tool which has a shape of the form which is to be generated on the workpiece, then that is called as the forming tool, right. If you want to bore a hole, that means to say in the shaft you want to make a hole, so then we call it as a boring operation. So, if you can take an analogy, there are a lot of tunnels which are to be made for metro as well as for bridges. They try to bore. So, in a bore what happens? The tool is attached to the tailstock and the feed is given to the tailstock. The spindle rotates. So, as and when it moves inside, the tool comes in contact with the workpiece and then you do. So, for a boring operation to happen, there has to be first a drilling operation. This is first and this is second. Drilling is to generate a hole. Boring is enlarging a hole. Right. And then if the workpiece or the tool is at an angle, then we try to make a chamfer. Taper is this, chamfer is very slight which is given on the top. Then we can also try to do parting off. So, parting off means here you are trying to cut the shaft into parts. So, it is called as parting off. So, here there will no be any feed along the workpiece, but it will be perpendicular to the axis, you get a feed. So, that leads to parting off operation. Then we saw using the lead screw, you can try to generate threads. The profile of the thread will be generated on the tool. When it sinks, it tries to generate the teeth profile. I have already talked about drilling. So knurling is an operation wherein which we try to generate a crisscross hatch pattern. This crisscross hatch pattern is generated by a tool which has two wheels. They try to plunge on top of the workpiece and then they try to create this profile. Knurling is not a subtracting process. Knurling is again something like a metal forming process wherein which you try to deform the material to generate the diamonds on top of it. This is used for better gripping. So these are all the operations which you can try to do it on a lathe machine. So here we have trying to talk about turning. So turning is an operation which is used to reduce the workpiece diameter to produce the desired shape. So there are two types of turning. One is called as rough turning, the other one is called as finish turning. In rough turning, we try to extract maximum material. The feed rates are higher, the depth of cut is higher. When we try to do fine turning, the feed rates are smaller and the depth which is given is also very small. In the sense it will be 1/10 the rough turning you will try to do in a finish, such that you get a smooth surface finish. So this is the tool, and then now we are trying to see what are all the forces which are involved. This is a tool. The tool is moving in this direction. So it is a turning operation. So here whatever we give or the resistance we get is called as the feed force. And then whatever we try, this is feed. Whatever perpendicular to the workpiece we do is called as the radial force. The resistance which is given to the tool which comes from the other direction is called as the radial force. So this is radial force, the opposite whichever is the feed force. And a resolution of these two at an angle of 45 degrees is the tangential force. Right. So this is radial force, this is radial force, this is feed force. The tangent of it is the Ft, which is the cutting force. Right. So that is tangential force. The tangential force is also comes which tries to move the workpiece down. The tangential force is otherwise called as cutting force. Right. The workpiece rotates. This is the depth of cut. The diameter, change in diameter is called as the depth of cut. The initial diameter was di. The final dimension, let us assume, is do. So di minus do will be the depth of cut. Okay. So I have explained all the forces which are there. I have left one, which is the feed rate or the velocity of feed which comes is Vf, which comes along the direction the feed force is given. This is step turning. Step turning is if you want to have multiple diameters on the same shaft, each one is, it looks like a step which is created. So this is a step. So this is called as the step turning. So it is reducing the diameter in two different diameters on a single shaft is step turning. What is taper turning? Taper turning is you try to rotate the tool post to a particular angle, and then you try to give a feed, and then you also try to move the cross line. The taper turning produces a ramp transition between the two surfaces. So it is a step which is there is intermediate. First is full shaft, then it is step shaft, then now it is ramp which is getting generated. The taper turning produces a ramp transition between the two surfaces with different diameters due to the angled motion between the workpiece and the cutting tool. So this is the taper turning. You can have forward taper turning, reverse taper turning. This is the chamfering operation. The chamfering operation is similar to step turning. The chamfering turning creates at an angle. So at the edge, we try to do a small thing. This is called as a chamfer. Similar to the step turning, chamfer turning creates angle transition of an otherwise square edge between the two surfaces with different turned diameters. What are conical turning or contour turning? The contour turning is you try to give a profile to the tool post. The tool moves in and out, so that creating a contour. So that is called as contour turning. In contour turning operation, the tool cutting tool axially follows the path with a predefined geometry. So you can have a dial or a mandrel which comes in contact with a template. So that is in turn transferred to the tool post. The tool moves up and down to create the contour. Multiple passes of a contour tool are necessary to create a desired dimension. However, form tools are produced to generate it in a single pass. Facing is done. So here this is the axis. So we are moving perpendicular to the axis. The tool is at an angle fed and you try to create a face. During the machining, the length of the workpiece is slightly longer than the final finished part should be. Facing is an operation of the machine, the end of the workpiece that is perpendicular to the rotating axis. During the facing, the tool moves along the radius of the workpiece to produce the desired path length and the smooth surface. Grooving. Grooving is something which is done in between. So you can try to have, facing was this, turning was reducing the diameter, taper turning was bringing the angle. Now grooving is move offsetted from that distance and then move only perpendicular to a certain depth such that a groove is created. The size of the cut depends on the width of the cutting tool. Multiple tool passes are necessary to create a groove. There are two types of groove operations. One is external grooving and face grooving. In external grooving, the tool moves radial into the side of the workpiece and remove the material along the cutting operation. That is called as external grooving. Face grooving is the tool machine grooves on the face of the workpiece is called as face grooving. So this is external grooving, what is shown to you. Then parting off grooving, when the advancement happen along the depth, it tries to remove this material from the shaft. So that is called as parting. Slicing, something like slicing, you rotate it and then you go remove it, right? That is called as parting. The process uses a tool with a specific shape to enter the workpiece perpendicular to the rotating axis and makes a progressive cut while the tool is rotating, or while the workpiece is rotating. So this is used for cutting the workpiece and the tool falls down. You see here the workpiece cuts and the disc has fallen down. The part catcher is often used to catch the part without getting damaged. This is the threading operation. Threading, you can see here, there is a feed rate, right? There is a feed rate, there is a pitch, right? So there is a pitch which is there between the threads, that is to be controlled by the tool geometry and the feed movement which is given. Thread cutting operation, in which the tool moves on the side of the workpiece, creating threads in the outer surface. You can have internal threads, you can have external threads. You can have multi-start threads also if you want. The threads are of uniform helical grooves of a specified length and a pitch. The deeper threads needs multiple passes to generate. Knurling operation, as I said, you have a tool which goes around. So you can see here, this is a knurling tool which has a diamond like cut on it. So now what we do is we just plunge this on top of a workpiece to create the knurling profile. The operation produces a serrated pattern on the surface of a part to give a better grip. The machining process utilizes a unique tool which consists of a single or multiple cylindrical wheels called knurls, which can rotate inside the tool holder. The tool holder is there. Inside the tool holder, these knurls, we plunge it against the workpiece to get this operation. So they try to create diamond like patterns. Drilling, so you can, the workpiece is rotating and at the tailstock you put a spindle and then you mount a drill there. So now you manually rotate the tailstock so that the drill advances and creates a hole. The drilling operation removes the material from inside the workpiece. The result of a drilling is a hole with a diameter equal to the size used in the drill bit. The drill bit are usually positioned either on the tailstock or on the tool post. You can start removing the material, creating a hole. What is reaming? The hole creation is done by drilling process. Reaming is an enlarging process, right? So if you want to enlarge a hole and improve the hole geometry profile, then we do reaming. So reaming, here the tool rotates and the workpiece is there which is mounted on the spindle. The tool rotates the ream enters and then it tries to create or enlarge the hole. Reaming operation, a reamer enters the workpiece axially through the end and expands the existing hole to the diameter of the required tool. It removes very minimal amount of material as compared to that of a drilling. So, boring is an operation where again the tool is mounted on the tool post or it can be mounted on the tailstock. So, you can try to give advancement of the bore. This is a boring bar. This is a boring bar. So, this boring bar has a boring tool here. It has a boring tool. So, this is the tool wherein which the rotation is given to the boring bar and the feed direction is given. So, it enters and then it tries to create or enlarge a hole. The boring operation, the tool enters the workpiece axially and removes material along the inner surface to either create different shapes or to enlarge the existing hole. So, reaming and boring will not generate a hole. Whatever hole was generated in drilling can be enhanced or improvised by reaming and boring operation. There is a tapping operation which is also there. So, here what do we do is we try to, the reamer is replaced by a tapping tool, in which a tapping tool enters the workpiece axially and cuts a thread into the existing hole. A hole is there, now you put a tap and then now you create a internal thread. In the threading operation is external, the tapping operation is internal thread. The hole matches with the corresponding bit size that can accommodate the desired taping tool. It is used for making threads on nuts. Now, let us try to see little bit on the cutting analysis. So, the rotating speed in turning is related to the desired cutting speed at the surface of the cylindrical workpiece, which is given by the equation this. So, here I can rewrite the equation. Cutting speed is nothing but pi d n. So, where pi is the circumferential thing, d naught is the original diameter, n is the speed with which it rotates, the RPM with which it rotates. So, if you want to find out the cutting speed V, it is nothing but pi into d naught into n, where n is the speed, V is the cutting speed which is given in meters per minute and d naught is the original diameter d. So, when I try to reduce a diameter from d naught to d final, so it can be done like this. D naught is equal to df plus 2d. So, what is d naught? D naught is the original diameter, which is equal to final diameter is df plus 2 times the depth of cut. 2 times the depth of cut. So, if you see here, what is d? D is this. So, 2 times d is also here, right. So, the d naught is here and df is here. This is df, this is d naught, and 1d, 2d, this is 2d. So, the turning operation reduces the diameter of the workpiece from its original diameter d naught to df. So, the relationship between d naught to df is d naught is equal to df plus 2d. If we want to find out the feed in turning, it is generally expressed in millimeter per minute or millimeter per revolution. The feed rate is nothing but n times that of the feed. What is n? N is the rotational speed or the spindle speed. So, what will be the time of machining is going to be length of machining divided by the feed rate will give you the time of machining. So, if you see here d naught, df, df and this is L. So, now time required for machining will be length of cut divided by the feed rate Fr. So, in order to have more direct computation of the machining time, it will be T will be pi d naught into L by Fv, that is feed rate. So, feed rate into velocity. The volumetric rate of material removal will be V into F into D. So, this is volumetric rate of material removal. So, with this you will try to have a feel what are the process parameters and how does these process parameters affect my machining time. So, friends, to recap what we saw in this lecture. Okay. So, before we recap, let us try to do these three simple exercises. 1. Collect at least 10 different parts which are cylindrical in nature and try to write the process sequence. What comes first, what comes next, what are all the operations involved. Collect 10 different parts, for example, camshaft, crankshaft, whatever you want to do, you can do. Next is you try to visualize if I wanted to have a taper internal thread. First of all, is it possible? If possible, how will you mount the tool and what all will be the processing sequence for generating taper internal threads? The third thing is, if I wanted to have a shift, for example, let us take a crankshaft. Something like this. So, there is an offset. There is an offset. If there is an offset, how do I machine on a lathe machine? How do I machine on a lathe? Okay. So, these are the three things which I would request you to try and practice or see, and then you will try to understand how do we go about. Well, friends, before I wind up, the recap of this lecture, what we have done till now is, first we will try to understand about a lathe machine we did, then important functions we did, what are the major parts in a lathe machine, then different type of operations in a lathe machine and different type of lathe machines we saw, and finally we did some cutting analysis wherein which we tried to have process parameters which can be used for machining, and finally we equated all these process parameters with respect to time. So, we found how to calculate the machining time. So, here are the references which are being used for preparing the slides. Thank you.